I want to just tell you a bit more about why we're here. If you think about it, we're here at a conference, look around, it's all about data. And we can see that in the industry, data is becoming the biggest asset for customers. And that to build a competitive advantage as a company, you're going to have to leverage your data. So we're constantly seeing that buying off-the-shelf software has been really useful, really good products, things like Okta, Salesforce, all of those sort of things. They're really great products, but to get that competitive advantage, differentiate yourself, you're going to need to leverage your own data. And that's how you can start becoming competitive, enabling your developers to build what they want to maximize your competitive advantage. And in my role, I get to work with some really great companies in all sorts of verticals. So I get to work with the likes of DWP, Boots, Compare the Market, and pretty much across the board with with all of their data problems. So if you think about Boots, throughout the pandemic, they had to completely modernize. They had to decide that, okay, they're not going to be able to just do in-store shopping. They're going to have to do stuff online. They're going to have to leverage their data, make that experience great for everyone. And even with that, you have the likes of DWP. Pretty big thing in the UK. They kind of control a lot of the stuff that we do, and they have a ton of data. And even SAP data, Haleon, which is the new, is the divestment of GSK. They're all building things with their data. And then my favorite customer to talk about, not up on the screen, is a small startup in Finland. And they do herd management. So they get to do tracking of reindeer, which is probably the weirdest use case I've gotten to work with yet. It was around Christmas time last year. So we went for a lot of jokes about Santa, Rudolph. Where on earth are these reindeer? But all of them come back to the same problems. They all need to leverage their data and they need to build with it. So what we're seeing in the industry is that you have these structures that have been built from architectures that are older than I am. They're over 40, 50 years old, and it's all based on that relational system. It's all based on being built with a legacy system where they're optimized to solve problems like storage is very expensive. If you look at, all of you have devices, some of you are taking photos. Those devices have a lot more storage on them than you're ever really going to get back when a lot of these systems were designed. And with those data structures, we've kind of kept them how they are, and we moved a lot of how we're doing application development. So most application development is done through object-oriented. You're looking for your objects. You want it to map nice and natively. You don't want to think about what was the business logic 10 years ago that made me put this schema together. And you want it to be nice and fluid, so you don't want that rigidity. You want to be able to decide, okay, I want to try this new feature. How much changes am I going to have to do to all of the different databases, all of the different systems in this application to just do one simple feature change? You just want to be able to quickly spin it up and go. So what tends to happen with a lot of our customers, some of the ones that I've worked with, is they start off, they have their application. It very nicely goes to their relational systems, and they realize that for their newest feature, they need a NoSQL database, or they need a caching layer, and they end up building something like this. They've added their time series, they've added their key value to maximize that use case, to use that feature that they need. That's all great, but I like to search things. I don't really like to have to do long queries, so I'm going to add a nice search engine on top of it. We're going to map something else in. And then even from there, we go back to my reindeer. We need an edge database. We need something offline. We need to go and figure out where on earth Rudolph is. Or you have a mobile one. So everyone here has a phone, and you want to be able to use your iOS, your Android, whatever other way of developing your application or for your users. But that's great, but I want some analytics on that. I want to actually leverage some of that data. So I'm going to build a data lake or add a nice enterprise data warehouse. So how familiar is this sort of a schema to most of you people out here? That's good. That's one business unit in the company. Now let's look at it a bit further. We have application A, so that's one business unit. Then we add another one. And that's fine. We have two systems here, two slightly different schemas. The interns come along. We'll add in another application. We're going to put the data warehouse nice and up and vertical, just to change it up a little bit. Then you have another application come in, and slowly throughout your whole company's lifecycle, you've gotten 5 to however many different applications being built, completely different schemas. And what happens when you come along and realize, oh, wait, now application A and application C, they should really talk to each other. How are we going to integrate that? And how does that all happen? And we end up with a fragmented developer experience that leads to a ton of different operational and security models that you then have to try and rationalize against each other. They end up with a lot of integration, so ETL, left, right, and center, and then you're copying all that data from everywhere and anywhere. And what we in Mongo like to call that is our data and innovation recurring tax. I personally, not a big fan of tax. Just as a concept, I don't like paying too much tax, and neither do we when we talk about our application development. So to eliminate this tax, there's kind of 3 major attributes that are necessary to do so. We've done that with our developer data platform. So we've done that by trying to build the best and greatest things with that. And with it, there's 3 key things that we think about. First of all, again, we're at a data conference, so how are we storing the data? At its core, MongoDB has its document data model. So we're able to represent our data in the same native sense as developers are thinking. You put it into an object, it's in a nice JSON-like format, and very simple to query. And we can even represent things like having your key value pairs, your graphs, your time series, whatever use case you have, while having it inherently flexible. So if you want to add that extra field for that new feature, instead of bolting on something new, you can just add the field into your database. No need to change up your schemas, no need to do anything there. And you can also put in that governance that you need to keep that flexibility as strict as you need if some developers like to go rogue. And then it also allows you to have your both semi-structured and structured data in that one place. So that's how we store the data. So data stored, all good. Now let's access that data. We want to unify that query interface. We don't want to learn 7, 8 different languages, learn all of these different ways to get the data back out. So we have a broad set of we can actually do a broad set of workloads with that one querying interface, where you can do your transactions, you can set up your analytical workloads, and even do search. So with Mongo, we've actually integrated Lucene-based search indexes. So we have the capability to go search through all your data. You don't need to bring in another system. You don't need to ETL it off and then try and reconcile it back into your data. It's all in that one simple place. And one of the customers I've been working with recently is a news broadcaster. And I was talking to them, and they explained it took them 6 months to spin up their search index. They talked me through it. We spent a good 45 minutes to an hour talking through each and every step of that. I then opened up Atlas, MongoDB's developer data platform, and showed them, yeah, you can just build a search index. You press like 5 different clicks, and I've decided I'm going to put it into English, Irish, and Arabic. Why not? Built it. It took maybe a couple of minutes to build up the whole index across their whole data set, so across a load of articles, and then I could just show them a quick search in our UI. They both loved and hated me. They looked at it being like, well, so you just told me I've wasted 6 months of my life, but super cool to do with that. And then, of course, you can get that analytics from it as well. So you can even see how many searches have been done on whatever keywords you want and build from there and then visualize it all in the one place. So you're able to do all of that. And now you're probably thinking, okay, well, we have a load of different ways we're doing our applications. We have a lot of architectures. We have got our distributed ones. We have some on mobile. So just to add to that, you're actually able to have all of those different application types. So you can have a website, you could have your mobile, you can have your Reindeer's Edge device, whatever you need, supported through that one unified query interface. And it's completely distributed natively with Mongo, and you can kind of set up a global one with, like, I think it's 5 clicks now, across pretty much any cloud environment. And you can then have that interface with the exact same data set for your mobile. So you can have that same core data of, so say the broadcaster, you have all your articles, you're querying on the mobile, you're querying on your edge device, you're querying on your distributed everywhere, all to that one data set through that unified interface. And then you don't want to even think about what's behind the systems. You can go for the serverless world. We don't need to know what computers are there. We don't need to know what infrastructure. You can just spin it up and go. Scale as you need and as your application is growing. And not just that, it is on a battle-tested environment. So it is a completely battle-tested platform. I showed you DWP at the start. They're running universal credit on MongoDB. That's kind of important data to keep fairly locked down. We don't really want that going anywhere. So we are completely secure with the most comprehensive of controls available, including the idea of even queryable encryption, client-side field level encryption, and a whole host of other things. And then we also deploy across 95 regions over the 3 cloud providers, so GCP, Azure, and AWS. You can kind of pick and choose. You can do all 3 of them if you wanted. You can decide to have some of your database in one place and some of it in another, or even query across all of your database across all of them. So you can leverage those cloud providers as you need. And it comes with the continuous uptime, because imagine if something like universal credit went down, probably wouldn't go too well. Or pretty much any of those logos I showed you at the beginning. If people can't get whatever they want online, they're not going to be too pleased. So we have continuous uptime and complete performance no matter what that scale is. And I've only mentioned a couple of our customers. We have over 250 million downloads across 35,000 customers in over 100 countries, and we've been growing constantly and constantly investing back into our platform. So some of those features that I've shown you were just released 6 months ago. Some of those features were released 8 years ago. We're constantly investing back into our platform. So that's how I believe you can build the biggest and greatest things with MongoDB's developer data platform. Thank you. Is there any questions?